Hi students, welcome to Swamy Sir's YT channel. Today we are going to discuss electric field topic in the electrostatics. So first, the definition of the electric field. The definition of the electric field is the space around a charge in which its influence can be felt by any other charged particle. That means this is the charge now. To find out the electric field intensity of this charge any point, we have to assume one test charge at that point. Suppose this is the Q, it is producing the electric field. This is the source charge now. From this charge at some r distance, okay, now we want to find the intensity of the electric field here. To find the intensity of electric field at this point, we have to assume one test charge Q0. This test charge should be very small than this source charge. Why? Because if this test charge is comparable to the source charge, then this test charge also produces the electric field. This will affect the electric field produced by the source charge. That's why this test charge should be very small. So where we want to find the electric field, at that point we have to keep the test charge. Now what is the intensity of the electric field at this point means, so this electric field will exert the force on this test charge. So at this point the intensity of the electric field is equal to the force experienced per test charge, will give the intensity of the electric field at that point. Now formula of the electric field is E bar equal to the force experienced per test charge. Okay, electric field is the vector quantity. Okay, it has the magnitude and direction. Next, what is the direction of this electric field? See now, if here I assume this capital Q is the source and the Q0 is the test charge. Suppose if that source charge is positive, so and at r distance from this source charge, here I am keeping the test charge. What is the direction of the electric field means, so if source charge is a positive, electric field direction is radially outward direction. Okay, and the force acting on this test charge also same direction of the electric field. Okay, now so radially outward only here also. In the second case, if the source charge is negative, okay, now what is the electric field intensity at this point? Okay, that means here the electric field direction, okay, electric field direction due to this source radially inward. So if the source charge is negative, the electric field direction is inward. If source charge is positive, and electric field direction is outward, radially outward. And here this electric field due to the source charge exert force on this test charge. This force also in the direction of the electric field. Okay, so that means the electric field direction also same as the direction of the force. Okay, here both are radially outward, here both are radially inward direction. And the next case what we are doing means, here we are assuming the uniformly distributed electric field. I am assuming the E bar is the electric field. So I am keeping one test charge, the test charge also positive. Okay, I am keeping the one unit positive test charge in the uniform electric field. Then this electric field will exert the force on this one. This particle also move in the direction of the electric field. That means if we keep the unit positive test charge in the uniform electric field, then this positive test charge will move in the direction of the electric field. In the second case, same here also electric field is a uniform electric field we are assuming. Now we are keeping the negative charge, test charge is here negative charge. So that means here if we keep the one unit negative charge in the uniform electric field, the force acting on this one is opposite to this one. Okay, that means this negative charge will move opposite to the electric field direction. If positive is there, it will move in the direction of the electric field. If the test charge is negative, this will move opposite to the electric field direction. That means force acting on this one is opposite to the electric field. Remember this one. And the next electric field is the vector quantity. Already I said the units of the electric field. What are the units means? So remember the units are Newton per coulomb. Here force per charge num. So force unit is Newton, charge unit is coulomb. Or one more unit is there, volt per meter. Remember these two units. Okay, and next dimensional formula also very important. The dimensional formula is m l t power minus 3 a power minus 1. This is the dimensional formula, very important, remember. Next, suppose due to the point charge, electric field formula is E equal to the 1 by 4 pi epsilon naught q by r square. So okay, electric field produced by a q charge is nothing but E equal to 1 by 4 pi epsilon q by r square. That means here this is the q, this is producing the electric field. So now what is the intensity of the electric field produced by this one at some point p point, this r distance from this q source. To find out the electric field intensity at this point, already I said we have to assume one test charge q naught. Now electric field intensity at this point is equal to the 1 by 4 pi epsilon naught q by r square. So here electric field is not depending on the test charge, it is only depending on the source charge. Okay, so here 1 by 4 pi epsilon naught place me, I am writing the k. Already in the previous classes I said k means electrostatic constant, it is equal to 1 by 4 pi epsilon. Now E equal to the kq by r square. This will give the magnitude of the electric field. Now to find the direction, so distance from source charge to the test charge where we want to find the electric field is r. Now in this direction we have to assume the unit vector r cap. This will give the direction of the electric field. Now in the vector form I am going to write the electric field. E bar equal to the kq by r square, and in this direction I am assuming the unit vector is r cap. This will give the direction. Now kq by r square into r bar. So that means vector have the magnitude and direction. Direction is indicated by the unit vector. Now from this r cap equal to, we can write r bar by magnitude of. So now at the place of r cap I am writing the r bar by r. R bar by r. This is the magnitude, this is also magnitude. Now E bar equal to kq by r square into r cube into r bar. Now E bar equal to k value I am writing. K is nothing but 1 by 4 pi epsilon q by r cube into r bar. This is the vector form of the electric field. Okay, this one is the magnitude of the electric field, this one is the vector form of the electric field. Okay, and next come to see graphical variation of E bar on x-axis due to the point charge. Due to the point charge, the electric field is E equal to the 1 by 4 pi epsilon naught q by r square. To draw the graph, observe carefully. Now see, this is the positive charge. So now near to this charge electric field is very large, and if you are going away from this one, electric field intensity decreases. Once you see now formula, E equal to 1 by 4 pi epsilon q by r square. Very near to is r tends to 0. R is very small, or either if we are considering x-axis, so then x tends to 0. If x tends to 0 means very near to this positive charge. If it is 0, x is nothing but here r, distance from this charge. R tends to 0. If r tends to 0, this 1 by 0, 1 by 0 will something by 0, something by 0 will give the infinity. That means at this point electric field is infinity. Okay, if very near to the charge, the electric field is very large, infinity, that means. So here we are moving in the positive x-axis direction, so plus infinity. So now near to this one r, here the electric field is infinite somewhere. Now if you are going away from this one, so E is inversely proportional to the r square. So that means r is increasing, electric field decreases. So electric field decreases, somewhere it will become 0. Okay, now come to this side, very near to the charge. Okay, na? Very near to the charge electric field is infinity, electric field equal to the infinity. But which direction we are moving? Negative x-axis. So keep the negative sign. So minus infinity. At near to this one, minus infinity. Now if you are going away from this charge, electric field intensity decreases. So here maximum, now decreasing. So at r, x tends to infinity, or r tends to infinity. Okay, at infinity distance, if r is infinity, something by infinity we will give the 0. That means electric field becomes 0. In this case also, it extends to infinity or r tends to infinity. Okay, at a long distance electric field will become 0. That means E tends to 0. Okay, these are the graph. Same way we have to draw the graph for the negative charge also. First you have to remember the formula. E equal to the 1 by 4 pi epsilon plus I am writing the k q by r square. So here vector form we have to write. Q means minus, so minus q by r square into r cap. This is the vector form. So here very close to this one, electric field is infinity. Electric field equal to the infinity. Okay, see now we are going in the positive x-axis direction. So now r cap is positive. Now if it is positive, positive into negative, negative. That means very near to it, electric field is infinity, but that is equal to the minus. So minus means here somewhere. So if distance is increasing, okay, x tends to infinity or r tends to infinity, then electric field tends to 0. That means here decreasing, decreasing, decreasing going on in this case. Now here we have to assume, okay, so very near to this one, electric field is infinity only. Okay, very near to it, infinity. So now r cap is going in the negative x direction. Negative x direction means r cap is negative here. Negative into negative, positive. Positive means, so here we have the electric field more. So this is the plus infinity. Very near to it, electric field is very strong, and more, that is a plus infinity. Now if we are if the distance increases, electric field decreases, somewhere it will become 0. That means whenever the rs tends to infinity or x tends to infinity, then electric field becomes to 0. So like this we have to draw the graphs. These graphs are very important. Concentrate on these graphs. Okay, see the first question on electric field. So 2 point charges, each having charge q. So each having charge plus q. The given diagram also are placed on the x-axis at x equal to minus a and x equal to plus a. This is the origin. So x equal to minus a, q charge, and x equal to plus a. One more q charge placed. Plot the variation of electric field on the x-axis. On the x-axis we have to plot the variation of electric field. So I am redrawing the diagram. See now here this is the origin now, and at x equal to minus a we have the plus q charge, and x equal to plus a we have the plus q charge. Okay, now I am dividing this one into the 3 parts. Okay, this is the first part, first region. This total from here to here, it is the second region, and this one is the third region. Okay, so before going to solve this one, I am going to write the electric field produced by the point charge formula. E bar equal to 1 by 4 pi epsilon naught q by r square into r cap. This is the vector form. Okay, so I am replacing this one. E bar equal to 1 by 4 pi epsilon naught is nothing but the k q by r square into r cap. Okay, remember this one. See the first side, first region. In the first region, this is the positive charge. Okay, now here, so electric field due to both charges we have to consider, but this point is very near to this charge, so the electric field produced by this one is a dominating here, electric field produced by this one is a very small here, so we have to consider electric field produced by this one only. Okay, now very near to this charge, okay, very near to this charge electric field is, that means here x tends to 0. This formula I am going to write rewriting k q by r plus I am writing the x, so x square into x cap. So if x tends to 0, so at the very near to the charge x equal to 0, then we will get E equal to the infinity. That means at 0 we will get the electric field equal to the infinity. Okay, but here we are moving in the negative x-axis. This is the negative x-axis direction, so now electric field is negative here, minus. That means very near to it electric field is negative. Minus infinity means somewhere here. Okay, if you are going in this direction away from this one, electric field decreases, and somewhere it will become the 0. Okay, so we will get here maximum, next decreasing, somewhere it will become 0. Where it will become 0 means whenever x tends to infinity, x increases, x tends to infinity, then E tends to 0. Okay, this side one first region completed. Now come to see the second region. If you come to see the second region, okay, in the second region what will happen means, so this is the plus charge, very near to this one electric field is infinity. Electric field is infinity. Now we are going in the positive x direction, so electric field is plus. Okay, so now the electric field is infinity here, so if you are going in this direction, decreases, it will become 0. And next here these two charges are equal magnitude, have the same sign. Remember one point, if two charges are equal in magnitude and have the same sign, the electric field is 0. The intensity of the electric field is 0 at midpoint. midpoint of line joining these two charges. Okay, now remember that point. That means wherever the electric field is 0, that point is called as the neutral point. And next, at a neutral point, the electric field graph cross that graph. Okay, that means see here, in this case infinity plus infinity here, so decreases, and it will become 0 here. Okay, next come to see this charge. Okay, so very near to it, electric field is infinity, but we are moving left side or right side? Left side we are moving. If we are moving left side means negative, so is minus infinity means here. So that means here, from here, if you are going away from this charge, electric field decreases, become 0. So here it is going in this direction and decreasing and becomes 0. Okay, this is the second region completed. Now come to see the third region, right side, very near to this one. Very near to this one, electric field is a infinity. We are going negative side, positive side, we have to see. We are going in the positive direction, means electric field also positive. So now electric field is very near to this charge, infinity. So if you are going away from this charge, electric field decreases and becomes 0. Electric field decreases and become 0. Okay, like this we have to plot the variation of electric field on the x-axis. Remember all these points. The second question, 2-point charges of plus 5 into 10 power minus 19 coulombs and plus 20 into 10 power minus 19 coulombs are separated by a distance of 2 meter, and find the point on the line joining them at which electric field intensity is 0. So remember this point. So they given the two positive charges only, plus q1 and plus q2, 2-point charges. These two are separated by the 2 meter distance, are equal to the 2 meter. If they give the they given two charges and both are same sign, then where the electric field intensity becomes 0 means the electric field intensity will become 0 between these two charges on line joining these two charges somewhere. So this electric field intensity is 0 near to the smaller magnitude, a charge which has the smaller magnitude. Suppose q1 equal to the plus 5 into 10 power minus 19 coulombs, and this one is the plus 20 into 10 power minus 19 coulombs. Okay, so this charge has the small magnitude, so electric field intensity is 0 in between these two charges only on line joining these two charges, but it is very close to this which has a magnitude small. Near to that charge, the electric field intensity will become 0. At what point we have to find? Suppose we are finding the distance of the electric field intensity 0 from this charge. Now suppose from here, somewhere here I am assuming the electric field intensity will become 0. This distance is the x. Now I want to find the distance of x from this charge. Now x equal to the, from first charge I am finding root q1 by root q1 plus root q2 into distance between the two charges. I given same formula in the Coulomb's law also, once you watch that Coulomb's law video. So now x equal to the root of q1 value is 5 into 10 power of minus 19 coulombs by square root of 5 into square root of 10 power minus 19 plus square root of 20 into 10 power minus 19. So in the numerator same value 5 into 10 power minus 19 only. In the denominator take the 5 into 10 power minus 19 as a common. Then here we will get the 1 plus, in this case we will get the square root of 4. Square root of 4 into 5, 20 into 10 power minus 19 we will get. This one will be cancelled out. We will, and into is in into r value is 2 meters. 2 here also 2 equal to the, this is 2 by 1 plus square root of 4. Square root of 4 means 2. 2 plus 1, 3. So 2 by 3 meters. So from this charge, the electric field intensity is 0, 2 by 3 meters. And from this, how much means to find that one? From the second charge, from here to here distance, we can consider y. So then y equal to the r minus x. R is a 2 meter, x is a 2 by 3. This will get 4 by 3 meters. Okay, na? So 2 by 3 is very near to this one. So here we will get the electric field intensity is 0. Okay, from plus q1 is 2 by 3 meters and plus q2 is 4 by 3 meters. So in this way we have to solve. Once watch the Coulomb's law video, same formulas and applicable here. Okay, next see the third question. Three equal charges each plus q are placed on the corners of an equilateral triangle. Okay, this is the equilateral triangle, plus q and plus q. The electric field intensity at the centroid of the triangle is, at the centroid we have to find. Okay, so centroid is nothing but the point of concurrent of medians. Okay, now this is the centroid now. So for this equilateral triangle, the centroid also act as a in center. Now in center is nothing but we know already, it is the point of concurrent of angular bisectors. Okay, angular bisector, this point we will use. Okay, see now due to this one, electric field is, due to the positive charge, electric field is radially outward. At this point electric field direction is in this direction, positive charge. Due to this positive charge, electric field direction is in this case. Okay, both are, this is going in this direction, this is going in this. First I am considering these two, later I will see about this one. Once you see now, so this is the angular bisector. So actually in equilateral triangle, angles are same. This is 60 degrees, this is 60, this is 60. Here this is angular bisector means, so this one is the 30 and this one also 30. Now for this triangle, this is 30, this is 30. So total is a 180. So 30 plus 30, 60. 180 minus 60, 120. That means here equal to the 120 degrees. So now this angle also, angle between these two also 120 degrees. Okay, so now if angle made by the, already we discussed in the forces, one force is here, one force is in this direction. If the angle between the two forces equal to 120 degrees, the resultant of this force is equal to the F only. In the Coulomb's law I explained. Here also same thing, the angle between the two electric fields is 120 degrees. The resultant electric field is equal to E only. This is in this direction, E bar. Okay, in this direction. Now the resultant electric field due to these two charges is vertically upward direction. Okay, completed. Now consider this charge. Due to this charge at this point, electric field, this is positive charge in radially outward direction, in this direction. Electric field is here. Okay, so due to these two charges, electric field is E in this direction only, and due to this charge also electric field is in this direction only, E bar. By means all the charges are equal in magnitude and same sign. This E bar is upward direction, this E bar is downward direction. Both are equal in magnitude, opposite in the direction. So cancel out, and the net electric field at the centroid equal to the 0. In this way we have to solve the problem. See the next question, a point charge of 100 microcoulomb. So charge they given Q equal to the 100 microcoulomb is placed at the 3 I cap plus 4 j cap meter. Find the electric field intensity due to this charge at a point located at 9 I cap plus 12 j cap meters. Okay, now to find out this one, see now this is the x-axis, now here it is the y-axis. Now the charge Q charge is at the 3 I cap plus 4 j cap here, and one test charge they are keeping at the here somewhere 9 I cap plus 12 j cap. Now due to this charge, what is the electric field intensity we have to find. So now electric field intensity formula is K into Q by, Q is the only source charge we have to consider. Q by distance between these two is nothing but the R, I am assuming R square, into the direction of unit vector, in this case is the R cap, so R cap. So to find out the electric field at this point, we have to find the magnitude of the distance between these two and this R cap. So that means, see now here here I am assuming R1 equal to the this 3 I cap plus 4 j cap. That means position of this point charge with respect to the origin is R1 equal to 3 I cap plus 4 j cap, and position of this one with respect to the origin is R2 bar equal to the 9 I cap plus 12 j cap. Here R bar equal to the R2 bar minus R1 bar. R2 is a 9 I cap minus 3 I cap is 6 I cap plus 12 j cap minus 4 j cap is a 8 j cap. So this is the R bar we got. Now we have to find the magnitude of this one. So magnitude of this one equal to the square root of x square. This is xi cap plus yj cap form is then a square root of x square plus y square. 6 square plus 8 square. 36 plus 64, 100 is nothing but the 10 meter. Okay, so why I am finding all this means, so we know r cap equal to the r bar by magnitude of r bar. Okay, so to find out the r cap we have to find the r bar and the magnitude of r bar. Okay, completed now. So from this we can write it as E bar equal to the direct formula I am writing k q by r cube into r bar. This formula is there. This formula we have to use. Okay, this is the formula. E bar equal to the k cube by r cube into r bar. Suppose see the options. So if the options are in terms of the vector form, then use this formula. Substitute k value is 9 into 10 power 9, q value is 100 microcoulomb, means 100 into 10 power minus 6 by r cube. R is nothing but the magnitude. Magnitude we got here 10 cube into r bar value already we found. This is the 6 I cap plus 8 j cap. If they ask the only magnitude, the formula is magnitude formula is k into q by r square. This formula only magnitude. So according to this question, in the options they will given value only, not given in the form of the vectors. So I am finding the magnitude only. So magnitude equal to the k is the 9 into 10 power 9, q is the 100 microcoulombs, 100 into 10 power minus 6 by r square. R value magnitude of the r is 10 square means 100. Okay, so now answer, the magnitude of the electric field equal to the 9 into, that means 10 power 3, 9000 volt per meter. Okay, in this way. Suppose if the options are in the vector form, now I found everything here. So formula is this one. If the options are in the vector form, substitute the values here. If the options are direct to value only, then use this formula and substitute the values. I given the two methods. The next come to see the fifth question. 5 point charges plus q each are placed at the 5 vertices of the regular hexagon. So regular hexagon shape. Okay, regular hexagon and plus q plus q plus q plus q plus q. Only 5 vertices of the regular hexagon. The distance of the center of the hexagon from any vertex of the vertices is a. That means this is the center. From here to any vertex is a. So I am drawing here. Okay, center to any vertex distance is a. This is the a now. Okay, this is the a. Okay, now the electric field at the center of the hexagon. At this center we have to find the electric field intensity. First see the corner charges. Okay, due to this charge, this is the positive away from this one. Okay, radial outward here E only, E bar. Okay, due to this charge electric field is in this direction, radially outward direction. Both are the same charges and both are same distance from the center. So at this point electric field due to these two charges are equal in magnitude, opposite in the direction, cancel out. The electric field due to this net electric field due to these two charges here is 0. Same manner, so electric field due to this corner two charges also become 0. Okay, now only one charge we have at this vertex. So due to this charge electric field is radial outward in this direction. So here we don't have the charge. If the plus q charge is placed at this vertex also, here net electric field will become 0. It will be cancelled out here. Okay, now but here this no charge present at this vertex. So the net electric field is due to this charge. Why? Because the electric produced by these two charges cancel out, these two charges cancel out. Now electric field due to this charge only in this direction. What is the electric field? Magnitude of the electric field means k. What is the source charge? Q by distance from source charge to the center is a. So a square. So k q by a square. This is also that k is nothing but 1 by 4 pi epsilon naught q by a square. This is the easy problem. Okay, see the next question. An oil drop carrying 6 electronic charges. Okay, this is the oil drop and it is carrying the 6 electrons. Okay, the mass of this one they given 1.6 into 10 power minus 12 gram. In gram equal to 10 power minus 3 kg. Na? So convert into this one is the kg. 10 power minus 15 kg. Okay, this is the oil drop now. With some terminal velocity in a medium, what magnitude of vertical electric field is required to make the drop move upward with the same speed as it was formerly moving downward with? Ignore buoyancy. So they are saying ignore the buoyancy force. Okay, first see up to this question falls with some terminal velocity in a medium. In a medium it is falling with some terminal velocity, so it is falling down with some terminal velocity. It is falling with some terminal velocity means, so terminal velocity means it is moving with the constant velocity. If it is moving with the constant velocity means acceleration equal to the 0. So now here we have the formula now. So here if it is falling down, okay, so now weight of this one is acting downward mg, but here if it is moving with the terminal velocity now, so it is falling falling freely under the gravity only, it means. So now whenever it is moving in the medium, some drag is acting on this one. So drag is always opposite to the motion of the drop. So drag is in the upward direction. The drag is nothing but the F. The drag is nothing but the viscous drag. That force is 6 pi neta r. In first year you will get that one. So in this case it is moving with the terminal velocity means here this drag is equal to the weight of this drop. So F equal to the mg. This is the first case. And the next say what magnitude of vertical electric field is required to make the drop move upward with the same speed. Whatever the speed it is coming down, so we have to apply the electric field to make the drop move upward with the same speed as it formerly moving downward. Initially with how much velocity it is coming down, to meet the same velocity, what is the magnitude of the electric field we have to apply in the downward direction. So now electric field is downward direction. We have the drop here, it has the 6 electrons now. So here if the electric field is acting downward direction, it has the negative charge. So electric field is in this direction, so the force acting on the negative charge is opposite to the electric field. That means this will move upward direction. If it is moving upward direction means the drag will act opposite to this motion of the drop. So drag is acting in the downward direction and weight also act in the downward direction. Okay, now weight also acting as a downward direction. So it is upward direction, force is acting, it is moving in the upward direction. Which force is acting in the upward direction? Electrostatic force acting in the upward direction. Now electric force equal to the, this is nothing but the drag. Electric force equal to the viscous drag EF plus mg. Okay, this is the second equation. Now already we know electric field formula, E equal to the F by Q. Okay, so now charge is nothing but the 6 electrons. After that we will write from this F equal to what we can write, E into Q. So electric force equal to the E into Q. So electric force I am writing EQ equal to the F plus mg. From my first equation F equal to what? Mg. Mg plus mg 2 mg. Okay, now we have to find the magnitude of this electric field. So magnitude of electric field E equal to the 2 mg by Q. Now 2 into mass of the oil drop is how much? 1.6 into 10 power minus 15. And G value is 10 by Q value. What is the charge? 6 electrons. Now 6 into electron charge is how much? 1.6 into 10 power minus 19. Okay, now 1.6 cancel out. 10 power minus 15, this 10 power minus 19 send upside. 10 power plus 4, 10 power 5 into 2 by 6 means 1 by 3. 1 by 3 into 10 power 5. Okay, this we can write it as the 3.3 into 10 power 4 Newton per coulomb or volt per meter. In this way we have to solve the problem. Okay, next come to see the next question. A block of mass m containing a net negative charge minus q. Okay, now this is the block m and it has a charge is minus q, placed on a frictionless horizontal table. Okay, and is connected to a wall through an unstretched spring or spring constant k. This is the spring constant, this one is the k. If the horizontal electric field E parallel to the spring is switched on, so now electric field is switched on. This electric field direction also they given in the diagram. Okay, then the maximum compression of the spring is, what is the maximum compression we have to find? Now electric field is in this direction, so electric field is in this direction. Okay, now negative charge is placed here, minus q charge. Now force acting on this one is opposite to the electric field direction. So due to this force, so this block is displacing in this direction. Suppose if it displaced x, okay na? So due to this force it displaced x, that means work done equal to the F into x. So due to this electrical force, this block displaced x. Due to this x displacement, something energy is developed in the spring. That energy is nothing but the elastic potential energy. So the elastic potential energy developed in the string, that is equal to the half k x square. Okay, so now here whatever the work done due to this force is due to the this electric field. So whatever the work done, this force is stored as the elastic potential in the spring. Now equate this work done with this elastic potential energy. Now F into x equal to the half k x square. So now here electric field they given, we have to find compression, maximum compression, x value we have to find, but F is not given here. We have to find the compression in terms of the electric field. Electric field is given. Now electric field formula E equal to the F by Q. So now from this F equal to the Q into E. Now F place I have to write Q E x equal to the half k x square. Okay, maximum compression x, 1x will be cancelled to send this side. So from this x equal to what we are getting, 2 q e by k. This is the maximum compression of the spring. Okay, see the next question. Four identical Q are fixed at the four corners of a square of side A. So four identical Q. This is the A, B, C, D square. It to four vertices, four charges Q, and side is A only. So the electric field at a point P located symmetrically at a distance A by root 2 from the center of the square. From the center of the square, see now this is the center. From center to the vertex distance is A by root 2. The length of the side is A na? So then the distance from vertices to the center is A by root 2. From vertices all centers is A by root 2, same distance we will get from Pythagoras rule. You have to do that one. And the next the question they are saying that the point P located symmetrically at a distance A by root 2 from the center. From this center A by root 2 means at this point from center to this P point is A by root 2. So this is the center. Okay, this is the P point. Now what is the distance from center to P point? A by root 2. Okay, now draw the line to here. That means here we have the Q charge. So the Q charge is located at the P point. Now draw the line. So then we will get in this case, this is the positive charge, now electric field is radially outward direction. Okay, here we will get the electric field is in this direction. Okay, now this electric field will be resolved into the components horizontal component and vertical component. Okay, so this is theta, this one also theta. So this is the A by root 2, O to B. O to B also distance is A by root 2 only. A by root 2. Okay, na? This is A by root 2, this is also A by root 2. From Pythagoras rule we will get this one. The value I am writing A. This value is square root of A by root 2 whole square plus A by root 2 whole square. If we do, then we will get this value is the A. Okay, now this is the B charge. Now same way we have to do the D charge also. For D vertical horizontal component in this direction we will get a vertical component here we will get. Okay, so horizontal component due to this charge will be cancelled out and vertical components will be add up. For this also horizontal components will be cancelled out and vertical components add up. All have the same charge and same magnitude, so net force is in the upward direction. This net electric field equal to the due to the four charges. No? So 4 into upward direction. This is divided into the component. This is the theta na? So this one will become E sine theta, this will become E cos theta. So vertical direction we have the E cos theta. So due to the 4 charges, net electric field in this direction is 4 E cos theta. Okay, now 4 into E is nothing but the K into Q by R square. R square means what we have to take here, R square. So that value is nothing but the from here to here. What is the distance? A square into cos theta. So cos theta, this is the theta na? So cos theta value is adjacent side, a by root 2 by hypotenuse is a into a. From this we will get 4 kq by a will be cancelled na? A square into 1 by root. So 4 we can write it as 2 into 2. 2 we can write root 2 into root 2 into kq by a square into 1 by root 2. 1 root 2, 1 root 2 will be cancelled. We will get 2 root 2 kq by a square. So now 2 root 2 k value is nothing but 1 by 4 pi epsilon naught q by a square. Okay, this is the answer. Suppose in some options they make the simplification, q by 2 will be cancelled out now, root 2 q by 2 pi epsilon naught a square. If the option they make you like this, q by 2 we can write root 2 into root 2, 1 root 2 will be cancelled, root 2 pi epsilon naught a square. Okay, like this we have to solve them. Okay, see the next questions. In this 9th question and 10th question, they are asking the direction of the electric field. They are not asking the magnitude of the electric field. Okay, see the 9th question here. The vertices, the charges at the vertices, plus 3q minus q plus 3q minus 2q. Okay, I am redrawing this one square. Okay, here minus 2q plus 3q minus q plus 3q. So okay, at center, so from here to here distance with this total diagonal length is 2a. So from here to here to here also a, same distance from the, this vertex is the same distance from the center. Okay, at this center, see now here the electric field due to this plus 2 charges away from this one radially outward in this direction. Electric field this due to this plus 3q away from this one radially outward. So here, okay, both the charges are same magnitude, same sign. We are finding the electric field intensity at the same distance from these two charges. So this both are equal in magnitude and opposite in direction. So due to these two charges, electric field intensity here it is the 0. Okay, now due to this charge, electric field is radially inward, negative charge. This is also negative charge in this way, in this direction, radially inward direction. Okay, this is the 1, this is the 2. So now E1 equal to the electric field at this point due to the one charge, magnitude only I am finding, 1 by 4 pi epsilon naught q by, from here to here distance is nothing but the a, total diagonal length is 2a and center is dividing into 2 equal to a is a. So q by r square means a square. Same way here also electric field E2 equal to 1 by 4 pi epsilon naught, source charge is 2q, distance from here to here is a square. Now electric field direction is in this direction, this is E2. Now electric field is in this direction, E1. So net electric field equal to the, this side the charges magnitude is more na, so in this direction only, that means E2 minus E1. So E2 value is 1 by 4 pi epsilon naught 2q by a square minus 1 by 4 pi epsilon naught q by a square. But simplification we will get 1 by 4 pi epsilon naught a square is the common, 2q minus q is nothing but q. Okay, this is the net electric field intensity at the center in this direction. What is the direction of this one means, this is the x axis, this side is the y axis they given. If you extend this one, this is the negative x axis. Now the net electric field direction is so 45 degrees below the negative x axis. Okay, now 45 degrees below the negative x-axis, and magnitude is q by 4 pi epsilon naught e square. Okay, this way we have to solve the problem. And the next, see the 10th question. 10th question also same manner we have to do. So this is the square. Now they are asking the only direction. Okay, so this is the plus 2q minus q plus q. This is the minus 2q. At the center we have to find square only. It is same distance from the vertices. So first I am considering the plus 2q and minus 2q to solve very easily. So radially outward direction in this way. Okay, so this one is a radially inward, so toward it. Okay, so if we divide this one into, resolve into the component, this side one component, this side one component. If we resolve this one also component, this side one component, upside one component, that means both are the same, that means same magnitude. So electric field produced by these two at the same distance, so equal. So now this side horizontal component, this side vertical horizontal component cancel out. Now both vertical components will be add up. Due to these two charges, net electric field is upward direction. Okay, now consider these two. Plus q charge na radially outward direction. So in this way going on. So due to negative charge radially inward, so in this direction. Now resolve into components. One is in this component, one is in this way. Okay, now this one also resolve into the components. So one is in this way and one more is in this way only. Okay, so here this horizontal components will be cancelled out. Why? Because these two charges are same in the magnitude. So horizontal component cancel out and vertical component so add up, and resultant is in this. So due to this q charges, the net electric field is upward, and due to this 2q charges, net electric field is upward direction. So magnitude of this charge is more than the magnitude of these charges. So net electric field is in the direction of the more magnitude charge direction. So in this case, so now electric field direction is in upward direction. Okay, in a simple way we can say this one. And I come to see the 11th question. So here they given the plot between the electric field and distance between the two charges. So that means here they given the charges, here they are arranging at the A and B. Distance between this is nothing but the R. This is the electric field. Now they plot the graph between the electric field and distance. Now they are asking what are the charges at A and B, what are the sign of the charges they are asking. Just remember here electric field formula I am writing 1 by 4 pi epsilon naught q by r square r cap. Suppose if it is negative charge, minus 1 by 4 pi epsilon naught q by r square into r cap. For negative charge electric field formula, for positive charge electric field formula. Next, one more point you have to remember. If the graph cut the x-axis, then neutral point exists. So when neutral point exists means, then if we have the charges, two similar charges, either two positive or two are negative, then neutral point will be exist. Neutral point means, so in between these charges somewhere the electric field intensity will become 0. When this electric field intensity will become 0 in between the charges means the charges have the same sign, either both are the plus or both are the negative. Okay, that means see now this is A, B, C, D. In B option, in the D option, in the both the cases this graph is cutting this x-axis. That means here these two charges are same, have the same sign. Okay, now either plus or minus. But here see now in the A option and in the C option, this graph is not cutting the this x-axis means here there is no neutral point. If there is no neutral point means the charges at the A and B have the opposite sign. So remember opposite sign. Okay, first find C here at the A charge. At the A, what is the sign of the charge we have to find. So near to A, electric field is maximum, that is equal to E equal to here plus infinity is there. When we will get the plus infinity, once you see here, if q is positive or negative, if q is, we are going in the positive x direction, r cap is positive here. Okay, R cap is positive. Next, if Q is negative, then we will get the negative sign here. If Q is positive, we will get the positive sign here. Here E equal plus infinity, we are getting plus sign we got, that means Q also positive. Now at the A, the charge is the plus, the charge have the plus sign. So now here we don't have the neutral point, no? Then opposite sign, opposite charges exist here, so opposite sign minus Q. Okay, same way here, see now here also, in this case also, here it is cutting the x-axis, that means your neutral point existed. Neutral point existed means these two charges have the same sign. Now if consider this one, it near to this charge, electric field is plus infinity, plus infinity. Same here, in this case here A is the plus Q. If this is plus Q, neutral point existed, that means these two charges have the same sign. This is also plus Q. Completed easily. Now come to see here, very near to this charge, E equal to the minus infinity. So we are going in the positive direction. R cap is positive. Completed. If Q is positive, then E equal to the positive. If Q is negative, E equal to negative. Q is negative, that's why E is the negative. So here charge is the negative. Q is negative here. So here neutral point is not there, means these two does not have the same charge. Opposite means here the charge is the plus sign, positive sign. So now come to see the this. Here neutral point existed means this both have the same sign, either positive or negative. Now consider here. So at near to this charge, E is the minus infinity. E equal to minus infinity means from the similar place, here at the A point we have the minus Q. If at the A we have the minus Q and the neutral point existed means these two charges have the same sign. That means here also sign of the charge is minus Q. In this way we have to solve the problems very easily.